Okay, we're working on number 14 on the bottom of page 3 of our notes. I actually made this video already, and then the camera froze, and then my computer shut off. So I lost my video, but my writing's on the paper, so that's why I'm not going to be writing too much. So this numerator, once in a while they'll give us one that can't be factored, and that's 1. Doesn't have any exponents, doesn't have a GCF, so I just leave it in +1. But the denominator you should recognize as a sum of cubes. Remember, 1's everything, and then of course m cubed. So when we see cubes, we do a little parenthesis and a big parenthesis, and we put our signs in. Same, opposite, always positive. So we have same as the problem, opposite of the problem, always positive. We have a little parenthesis and a big parenthesis. And remember, for our little parenthesis, we do cube roots. Cube root of m is m. Cube root of 1 is 1. Then we had another acronym for our second parenthesis, which was square, multiply, square. So we square the first term, m times m, to get m squared. Multiply the first and last. 1 times m is 1m. And remember, we don't change the signs. The signs are set in soap. Don't change them. Then we square the last term. 1 times 1 is 1. And then I see that this is common, and I put this in parentheses just so you could see it was one factor. So anything divided by itself is 1. And guess what a lot of students write for their answer? They write that. Don't do that. There's a 1 up there, and you can't ignore that. It's 1 over. But when you write that for your answer, that's saying that you think 1/3 and 3 are the same number. 1/3 and 3 are not the same number. I'd much rather have $3 million than 1/3 of a million. So when 1's in the numerator, keep it there. That's why every time I cancel, I always put the 1 so I don't lose it. So then my answer is going to be 1 over m squared minus m plus 1. So don't make that mistake of losing the 1. Okay, next we're going to talk about opposites. So like I said, I already did this video, so things are written, but I will still explain it for you. So opposites, get my things in the right screen, a little bit blurry, are things like 5 and -5. When I divide opposites, I get -1 because a positive divided by a negative is negative. 5 divided by 5 is 1. So how do we deal with opposites? So I'm showing you the steps right here. How we deal with opposites is we write them in the correct order first. So this is a -a and a positive b. And then we learned back in chapter 4, we never want our leading coefficient to be negative. So we pull out a -1 GCF, divide each term by -1, and we get positive a and negative b. So this is the same thing as that. So we could say b minus a can be replaced with -1a minus b. And sometimes I have to convince students are like, I don't know if I'm buying that. So distribute. -a, there it is. Positive b, there it is. So we've just put it in the correct order and factored out a GCF. And that's so that we can cancel common terms when the time comes, because we don't write our terms backwards. We write them in the correct order. So we need everything in the problem to be in the correct order. So here's an example of something that's in the wrong order. So I take the negative out, and I can put it with the numerator, I can put it with the denominator, or I can put it out in front. And I showed this example. This is actually on an 092 test or 090 test or 091, whatever class you took or didn't take. And it asks if these are all equivalent. Yes, they are. Just like all three of these are equivalent. As long as there's one negative in the problem, they're all the same. Now, if you had a negative here and a negative there, then they're not the same. Calculators and ALEX don't like this, so generally we write it one of these ways. This is the way most people type it. This is the way most people write it so they don't lose it, because sometimes this tends to run into the fraction bar and students lose it. So that's why we kind of like to have it up there so it's real obvious. Okay, so when we have something backwards, we're going to turn it around forwards and take out a negative just like we did up here. Okay. So on this first problem, I see that this first term or first polynomial is written backwards. So I'm going to change it to negative n, positive 5. Remember, we always keep the signs with it that are right in front. So negative n, positive 5. Numerator or denominator stayed the same for now. Then we go, oh, I can't have a leading coefficient of negative 1. I need to take a negative 1 out. And when I divide by negative 1, I get positive n and negative 5. My denominator is a difference of squares. So a difference of squares tells me to do one positive, one negative, and do the square roots. N plus 5, n minus 5. I just didn't like the way they did this one. That's why I redid it, because they didn't show the negative being taken out. So that's why I redid it up here, just FYI, because they just showed canceling opposites and get a negative 1, where most teachers will want you to do this process to show why you got the negative 1. So turn it around the correct way. Negative n, positive 5. Take out a negative 1 because of that. And when you take out a negative 1, that changes the signs. Positive n, negative 5. And then we factor the difference of squares. You can see the 1 there. So my answer is negative 1 in the numerator over n plus 5, which is the same thing they got, but I'm just turning it around rather than canceling opposites. So this is number 2 on your test, and I think this is the one that's closest, the example. I also highlighted 15 just because I wanted one where we worked out, but this is almost identical to number 2 on your test. So very good one to study. So let's just write number 2 on the test. Okay, so let's take a look at this next one. So the first thing I notice is that the polynomial in the denominator is written backwards. So I keep the numerator the same, x squared plus, and I put the 1 in because we like the 1 when we're factoring, and I turn the denominator around, negative x squared, negative 5x, positive 14, making sure to keep all the signs that are in front of it with it. Negative, negative, positive. Then I decide, oh yeah, I can't have that negative, so I take a negative out in front. And that's going to change all the signs when I divide by negative. Positive x squared, positive 5x, negative 14. So now I just have 2 normal problems like we had on the last section. This says the signs are different. This says the largest one's plus, so factors of 6 that subtract to 1 are 3 and 2. Largest number plus, so x plus 3, x minus 2. So this is what I notice a lot of students do wrong on this one on the test. They lose the negative. They start factoring this and they don't carry it. So first thing, before you factor, put that negative in front of the parentheses. And then we have signs are different. Largest one positive, factors of 14 that subtract to 5 are 7, 2. I made my largest one positive. So x plus 7, x minus 2. The x minus 2's cancel. So I end up with negative x plus 3 over x plus 7. Or you could write it like this. So what I want you to be aware of is this is an okay way to write it, maybe the preferred way on Alex, but if you decide to keep the negative with the numerator or denominator, know that you have to keep the parentheses. So that's why I like this, because it gets rid of the parentheses when it's in front. But if you want to list the negative down here or up here, the parentheses must stay behind the negative. Okay? So you could write your final answer like this, which is the least preferred. We don't like negatives in the denominator. Or you could write your final answer like this. Or you could write it like this. Just when the negative is with the numerator denominator, it does have to stay in parentheses. Okay, let's take a look at the next two. They're pretty easy ones. So I notice this is backwards. Remember, my constant's supposed to be last, so I turn it around and it becomes negative x positive 2. And because the leading coefficient's negative, I am going to take out a negative on the next step. This, you should notice, is a difference of cubes. So we learned with the difference of cubes, you do SOAP, same, opposite, always positive. Then we do cube roots. Cube root of x cubed is x. Cube root of 8 is 2. And then the square, multiply square. Square the x squared. Multiply 2x. Square the 2, 4. So then I need to pull my negative out of there. So I put the negative 1 in front. When I divide this by negative 1, it becomes positive x. When I divide this by negative 1, it becomes negative 2. Bring this over, and then look what we have. X minus 2 divided by x minus 2 is 1. So my final answer is negative 1 over x squared plus 2x plus 4. Okay, last one. So I see the denominators written backwards. So the first thing I do is write negative x positive 10. So my numerator, and do you know how many people don't recognize GCF? That's the first thing you're supposed to look at forever is GCF. So this one has a GCF of 2. When I divide each term by 2, so 2 goes out in front, I get x minus 10. In the denominator, I don't want that negative, so I'm going to take a negative 1 out, divide this by negative 1, divide this by negative 1, and I'm going to get positive x negative 10. So then in the denominator, I'm going to write negative 1 times x minus 10, and then x minus 10 divided by x minus 10 is 1. So my answer is 2 divided by negative 1, which is negative 2. So, moral of the story, this section, if you have a polynomial written backwards like this, the first thing you do is write it forwards in the correct, they call it on Alex, descending order, keeping the signs with it. If your leading coefficient is negative, then you take out a negative 1 in front of parentheses. Don't lose it. That negative has to be part of the answer. See how I never lose it? Divide each term by negative 1 and get your new polynomial. So then you keep that negative there, and it plays a part in the answer. Just like here, negative x plus 2. Take out a negative 1. Put it right there. Don't lose it. And then that turns out to positive x, negative 2. So then you do your regular canceling. And like I said, the negative 2 remains part of your answer. Okay, we'll start 5.2 in the next video.